Hi students, so welcome to the session. I am Dr. K.Varada Rajkumar, Associate Professor, Dept of CSE AIML, MLR IT, Hyderabad. In today's session, we are going to learn about the Q ADT, Q operations. So overview of today's class. First, we are going to know the definition of Q ADT. Then we discuss about different applications of Q ADT. After that, we are going to learn what are the different Q operations. So outcome of this lecture is, after completion of this lecture, you all are understand what is Q ADT and you all are understand what is the purpose of Q and you understand basic operations. So definition of Q. Q is an abstract data type that represents a linear collection of elements. Okay, so Q is also similar to stack. So this is also, so Q is also linear collection of element. So linear collection of elements. Linear means the elements are stored in continuous memory locations. Okay, in Q, the addition of elements we called as NQ is done at one end called rare. So this is important. Okay, we insert the element into Q using one variable and one end called as rare. And the removal, that means deletion, removal of elements we call as DQ is done from the other end called front. Okay, in stack we insert an element or delete an element using one variable called as top. Okay, in Q the insertions are done based on a variable called as rare and the deletions are made using a variable called front. Okay, you remember these two names, rare and front. So rare is for insertion, that is enter an element into Q. So front is for delete an element from the Q. Okay, another important point is Q follows the first in first out principle. Stack follows last in first out, LEFO, last in first out. Q follows first in first out principle. So meaning that the element that has been in the Q the longest is the first one to be removed. That means, so FIFO means first in first out. For example, so this is the Q. So this is the Q. If we insert numbers 10, 5, 15, 25, 35, 18. Now the 10 is inserted at first. So the deleted element will be 10 in Q. Okay, so that is a FIFO. In stack, last in first out. For example, this is the stack, then the deleted element is 18. Okay, so that is the difference between stack and Q. Stack is also linear data type, Q is also linear data type. That is the similarity. The difference is the stack follows LEFO principle, Q follows FIFO principle. Okay, the Q ADT does not provide direct access to its intermediate elements, only to the front and rear elements. Okay, here we are going to insert the element at using rear value, we are going to delete the element using front end. Okay, so we does not have direct access to the intermediate elements in the Q. Okay, so this is the definition of Q. So what is Q? So Q is a linear data type. We are going to insert the element, the function is called as NQ, and we are going to insert the element with the help of one variable called rare, and delete the element from the Q is known as DQ, and the deletion is made using a variable known as front, and Q follows first in first out principle. So this is the definition of Q. So what are the queue applications? Why we learn queue? Okay. So one is BFS algorithm, print spooling, task scheduling and buffering. So BFS is an algorithm. In that algorithm, we are going to use queue data structure. So queues are used to traverse and explore nodes in graph or tree level by level, so which is useful in algorithm like BFS. We have two types of algorithms in graphs traversing. One is DFS, another one is BFS. In DFS we use stack. In BFS we are going to use queue. Okay. So these algorithms we are going to discuss in future videos. So next application is print spooling. So print spooling means when multiple print jobs are sent to a printer. So for example, you print 5 documents one by one. Now they are stored in a queue and processed one by one. So queue means first in, first out. So first job assigned that will be executed first. And task scheduling. Task scheduling in operating system, tasks are often scheduled using queues to ensure fairness and orderly execution. So what it means? If you allocate more than one task to processor, now this processor can execute based on the first in, first out. So first in task is going to be completed first. And buffering, so queues can be used as buffers to handle data between processes that operate at different rates. In buffering also we are going to use queues to store the data. Okay. So these are some of the applications of queue. In BFS algorithm we are going to use the queue data structure. In print spooling we use the queue, and task scheduling and buffering also we are going to use queue. So now we see queue operations. Okay. In any data structure we are going to do insertion and deletion and display. Now in queue the insertion we called as NQ, enter an element into queue. So deletion we called as DQ, delete an element from the queue, and display we called as display only. And we have another two functions. One is empty. So for example, if you want to delete an element from the queue but the queue is empty, then we are going to use this function empty to know the queue is empty or not. And insertion, when we insert an element into queue, if the size of the queue is 5, already I insert the 5 elements and now I try to insert 6th element. In that case queue is full. In that case we are going to use this function to find the queue is full or not. Okay, these are the basic operations. Now we see one by one. So NQ adds an element to the rear of the queue. DQ removes and returns the element from the front of the queue. Empty checks if the queue is empty and returns true if the queue is empty, false otherwise. Is full, check if the queue is full, returns true if the queue is full, false otherwise. Display function, so display all the elements in the queue. Okay. So now we discuss one by one. So first function NQ. So that means you try to insert an element into queue. So here all the insertions and deletions are made by using two variables known as, one is rear, another one is front. Okay. So initially I am taking both the values as -1. So rear equals to -1, front equals to minus 1, and let us assume this is the array. Let us assume the size of the array is 5. So 0, 1, 2, 3, 4. These are the indexes. So let us assume the array name is Q. Okay, this we called as initialization. Now I want to insert an element into Q. So NQ, if I call NQ 10. So what it means? Now I want to insert 10 into this Q. So where I am going to insert? Q of 0. And you all remember all the insertions made using this rear only. All the deletions we are going to done with the help of front only. Okay. So now I want to insert. So increment the rear value. So now the rear, initially the rear equals to minus 1. Now plus plus rear plus plus. So now rear becomes 0. Now Q of 0. Q of 0. That means Q of rear equals to, so Q of rear equals to this element 10. So now what is the rear value? 0. So Q of 0 equals to 10. Okay, inserted here. Next again, if I call NQ 20. Now again rear plus plus. Now rear value becomes 1. So Q of rear equals to 20 now. So 20 is inserted in, so Q of 1. Again if I insert NQ 30. Again same rear plus plus, so it becomes 2. Now Q of 2 equals to 30. 30 is inserted here. Now again I want to insert NQ 40. Again rear plus plus, Q of rear equals to 40. Now what is the rear? 3. So Q of 3 equals to 40. Again if I call NQ 50. Now again rear plus plus, it becomes 4. So Q of 4 equals to 50. Now insert. That's it. So next function DQ. So DQ means removes and returns the element from the front of the queue. That means from here. So this is the front. Okay. So here it is a rear. So let us assume this is the array Q. Array name is. Now you identify. So these are the numbers I stored. Now what is front value and what is rear value? So rear value is 4. So these are the indexes 0, 1, 2, 3, 4. Okay, rear value equals to 4. So what is the front value? 0. So initially front equals to minus 1, but when we insert first element into Q, then I make front equals to 0. So this we are going to discuss in next lecture. Okay, now I want to delete. So this is the front. So this is the rear. Okay, now I want to delete. That means I want to delete the first inserted element, that is 10. So I am going to assign this number to a variable. For example, item equals to Q of front. So Q of front. Now 10 is assigned to item. Now I am going to print the item. After that front plus plus. Front plus plus. Now the front value is 0 incremented by 1. So now this is the front. Okay. Now if I want to delete one more element, again same, item equals to Q of front. That means 20. 20 is assigned to item and I increment the front value. So now this is the front. Okay, 1 becomes 2. Okay. So this is about DQ. Now if we delete all the elements, now the front reaches to rear. If front equals to rear, what it means? It means that the array is empty. Array is empty. So again I am going to make front and rear both values equals to -1. Okay. So this is about DQ. Now you observe that here the Q is empty, but I want to delete one more element from the Q. In that case, we are going to call is empty function. Is empty function. So what it returns? Is empty function returns true. The Q is empty. Here the Q is empty. So how we know that? If rear value equals to -1. That means the Q is empty. Okay. So last function, display. Let us assume these are the numbers. So now what is front value? Front value equals to 0, rear equals to 4. Means this is the front, so this is the rear. Now I want to display the elements in the Q. So I start from the front and I traverse up to rear. So it prints 10. Initially I am taking variable I equals to front and I less than or equals to rear, and every time I am going to increment I value I plus plus. Okay, and I am going to print the value of Q of I. That's it. In first we print 10, then I check the condition 0 less than or equals to rear. In this case rear is 4, true. So we print the Q of 0 and increment the I value, and we repeat this loop until the I value is less than or equals to rear value. In this case what is output? 10, 20, 30, 40, 50. So let us assume, for example, in Q there is only 3 elements. Now what is the rear value? Rear value equals to 2 now. This is the rear. So now also same code. I equals to front, I less than or equals to rear, and print the value and increment the I value. So in this case the output is 10, 20, 30. So for example there is no elements in the Q, but I want to try to print the elements in the Q. In that case also we are going to call is empty function. Look, what is the condition? Rear equals to -1. We are going to check. If rear equals to -1, then it indicates that the Q is empty. Okay. So this is about Q operations. So coming to Q disadvantages, here we are going to delete the elements using front. So for example this is the size 5, 0, 1, 2, 3, 4. Now I insert the element 10, 20, 30, 40, 50. Now this is the rear and this is the front. Now if I delete, so this is the front now, so 10 is deleted. Now if you observe that I want to insert number 60, here there is a scope to insert an element into array, but we are going to insert the elements using rear only. What it means? Space is available, but we can't able to insert the data 60. So that is a disadvantage of Q. Okay. The operations such as insertions and deletion of elements from the middle is not possible. So that is also one of the disadvantages. We cannot delete 30. We delete 20, then only we are going to delete 30. In Q, a new element can only be inserted when the existing elements are deleted from the Q here. So that is also another disadvantage. And uneven space utilization. So this is the example for uneven space utilization. Summary of today's lecture. So first we discuss about Q definition. So Q is an abstract data type that represents a collection of elements where elements are added at one end and removed from another end. it follows first in first out FIFO principle, and insertion an element into queue using a variable called rare. So deleting an element from queue using a variable called front, and the disadvantage of queue is, so uneven space utilization is the disadvantage of queue here. Okay. In next class we are going to learn how to implement queue using arrays in C programming. If you have any doubts on this lecture, so place your doubts in the comment section. I will answer all your questions. So thank you.